Hey everybody. So today's lesson is going to be looking at population and what's caused the population to grow over time. Sometimes a little more slowly, sometimes it's really taken off, and then what might cause that population to start actually declining some. So this is kind of our general overarching question for a lot of this population segment, population unit. What are those political, social, economic consequences of the rapid growth in population over the last 200 years? And so uh, let's take a look. Here's one quote that this person came up with in 1968. 1968, they were really starting to worry about what they called the population bomb, and we'll probably take a look at a video on that. But it was this fear that, look, the Earth has a carrying capacity. How many people can the Earth actually have on it, and still be able? Can we still feed ourselves? And so, there was this fear that we were starting to hit this number, that the number of people was going to outstrip the resources of Earth. And so, and this is a reasonable quote, logical quote: a finite Earth, so limited, can only support a finite population. So there is a certain amount of people that Earth can support. And so this person was arguing that population growth must eventually equal zero. And so the debate, in theory, he's exactly right. But the debate is when do we reach that point? Because as we progress as a society, technologies change, and we are better able to adapt to our new situations. And so, if you look at technology in farming, uh, it has kept up with our population. We have enough food on Earth to feed everybody. Now, how are we using our resources? Are we using them responsibly? Are we using them sustainably so they can last us into the future? Those are all questions that are good to debate, and worthy of debate. But we are not at this point yet. There was a big fear that we had almost reached that point, but we're not there yet because of technology and because of some other things that we'll talk about. But technology is saving us from ourselves on some level. All right, so let's take a look at the population growth and decline. Actually, let's just use this slide. So this is showing us 12,000 years of U.S. population. All right. And so you can see back here in 10,000 BCE, so that's a little over 12,000 years ago, we had about 4 million people. All right. And so over the next 10,000 years, we grew to 190 million people. So remember, the population of the US right now is about 330 million people, something like that. And so, this is the population for all of Earth. So anyway, so you can see it's this very, very slow increase over time. And so, but take a note here, what happens. And obviously, it doesn't take a rocket scientist to see the incredible jump in population. And most of that is due to industrialization. All right, it has done incredible things for our ability to sustain ourselves in a more comfortable way. All right, our lifespan is increasing, our infant mortality is shrinking, and so it's there's good and bad with everything. There's been some negative sides of industrialization for sure, but as a net benefit, uh, looking at the overall benefit of it, uh, you know, we wouldn't be able to do this without going through industrialization. So, anyway, so you can see, this is marking off every billion people for the most part. So we had 2 billion here, 1928. Took us 32 years to get another billion, then 15 years, then 12, 12, and 12 years. And so you can kind of see this pattern, but just take a look at the overall picture. So in the last couple hundred years, the population has taken off like nothing else in history. All right. So this is our population growth over the last 200 years. This red line is representing our rate of growth. All right. So you can see over on the left-hand side, it's got percentages. And so that is the rate of percentage growth in population. And under here, this is our actual total population. So you can see throughout the last 200 years, 250 years, however long they're measuring, you can see, actually it's 350, sorry, but you can see that it is growing over time. Okay, it's never dipped. Now, what I want to make sure you can start to understand, if you don't see this already, and this will be applicable to other classes. So if we have this rate of growth, so take a look here in 1750, we had a rate of growth of 0.6%, and then by 1800 we had a rate of growth of about 0.4%. And so the population didn't decline, all right? So this is still growth, but it is less than before. And so, we do still see this increase in population, but it is coming at a decreasing rate, all right? And so the rate of growth is decreasing, but as long as this red line is positive, if we come over here, so here's a 0.1%, that's where they expect us in 2100. If this red line came down here, below zero to like -1%, that would be, then you would see a decrease like this, all right? And so again, this is increasing at an increasing rate. This is increasing at a very increasing rate. And so you can see this big decline here. Is the Earth's population still increasing? And the answer is yes, but the rate of increase is slowing pretty dramatically since 1970 or so. So we peaked out somewhere around 1970 at 2.1%. And so you can see this very precipitous drop in the rate of increase. And again, as long as this red line is positive, you're going to see a growth rate. Alrighty. But this is, here's our industrialization impacts when industrialization is kind of kicking in a big way, and you can see the rate of growth just starts to skyrocket. All right. So a couple of numbers to look at to measure some of these growth rates, and we'll also be looking at death rates. So the first one is what we call a crude birth rate. And so this is the number of people born per 1,000 people in a country. All right. And so I think, I can't remember, one of the slides later on. So let's say that in the US, our crude birth rate is 18. That means that for every 1,000 people in the US last year, 18 new people were born. All right. And so that's all it is. Total fertility rate's a little bit different. Total fertility rate looks at how many children on average a woman in a country would have. And so these numbers generally track pretty similarly, but the total fertility rate looks at or takes into account the culture of a country. All right, if you have a more agrarian farm-based country, especially like the world used to be, you would have very high total fertility rates because if you are living on the farms, then they would have more children. The other reason they would have more children is because of high infant mortality. All right, because not all those kids would make it. But anyway, the difference between these is this is just a raw statistic, and this kind of is as well. But this is going to take culture into account to a decent level, and this is just how many per 1,000. All right, so total fertility rate accurately reflects cultural norms. So let's take a look at a place like Europe. So in parts of Europe before 1800. Women had 6.2 kids per female. All right, that was the average. And so today, that is a lot lower. It might be 2 or 1.5, something like that. I don't have that with me. I should have looked it up. But today it's a lot different because they're not an agricultural-based economy. They've moved into cities, the families have gotten smaller, and so it's a different culture than it was, and so this total fertility rate is going to drop, and you'll also see the crude birth rate drop as well. All right, and so again, I was telling you that these two things track each other pretty well, and so this top one is showing us the total fertility rate, and this is 2016, and so you can see that the total fertility rates are higher in African countries, and the crude birth rates are higher in African countries. And so, again, there will be some similarities. This is birth rate down here. This is per 1,000. Here's the U.S. We are, looks like this color. And so we're somewhere between 12 and 15. But anyway, so there are definitely some similarities here, but there is a technical difference in the definitions. All right, here's the crude birth rates. This is looking at 1960. And again, this is per 1,000 people. All right, so this is saying, look, in the world, and let's just pick 1960. So there were 32 births per 1,000 people in the world. All right, and now down here, we're at somewhere around 18, and so we've gone from 32, or a high of 36, down to 18. So that crude birth rate has been cut in half in the last 50 or 60 years. All right, here's the crude death rate. All right, so again, we were at 18 in 1960. Now we're down to what, 8, 7.5, something like that. And so the crude birth rate has dropped as well, and that's because of better nutrition, better health care, things like that. All right. Now, we have to do a couple of calculations. And so you're going to have 3 formulas, I believe it is. So this is the first one, calculating the population growth rate. And so all that is looking at the crude birth rate, all right, which is here. So the crude number of births, then the crude deaths, divide that by 10, and that will put it in a percentage term for you to do. So, for example, if you have a crude birth rate of 40, crude death rate of 30, that's 10 over 10, which is 1%. All right, so do this math real quick. So suppose a country has a crude birth rate of 17, a crude death rate of 12. What is the population growth? All right, and so again, to set this up, this is just births minus deaths over 10. So that'd be 17, which is the crude birth, minus 12, all that over 10, so that's 5 over 10. And so this population growth rate would be 0.5%. All right. And then we're going to look at a number in just a second that would tell us, okay, at a 0.5% growth rate, how long would it take for that to double? But I'm not quite there yet. So let's take a look at this. These are actual numbers that I pulled. So crude birth rate, crude death rate, so for different countries. And so you can see, here's our population growth rate. So Ethiopia has 2.5%, which is a pretty high growth rate. So they have a birth rate of 32, death rate of 7. So again, this is just 32 minus 7 over 10, and that gives us this 2.5%. So you can kind of go through. Fiji's at 1.3. Note Finland, so these parentheses in Excel, that's where I did this, means negative. All right, so it's negative growth rate in Finland, it's a negative growth rate in Germany, it's a negative growth rate in Japan. So that was one of the problems we were talking about with this population pyramids, that they start to come in on themselves a little bit, invert. And so, you know, how does a country deal with that? And we talked about that in the last video. So this just gives you kind of an example. So you can see here, the crude birth rate in the US is 12, the crude death rate is 9, and so we have this 0.3 population growth rate. Now again, this does not include immigration. So our overall growth rate as a country could be higher because of immigration. All right, so this is just based on births and deaths. All right, so the rule of 70, and really this the rule of 72, but we're not going to stress on it. And when you do economics, you'll probably come across this. They use it there, but it can be used in any subject. It's just trying to measure, given a certain growth rate. So we did, you know, 0.5%, 2.5% for Ethiopia. You know, let me go back. So looking at these, so here's our population growth rate. And so, oops, I skipped one. Sorry. We'll come back to that in just a second. So let's calculate growth rates. All right. So given birth, we're going to calculate birth or death rates. I'm sorry. And so birth or death rates is just the total number of births divided by the population, or the total number of deaths divided by the population. All right. And so here's an example. Let's say we had a country with 23,000 births, 942,000 people. That gives us a birth rate of 2.5%. All right. And so go ahead and pause the video. So using this formula, all right, go ahead and pause the video and see if you can calculate this one out. All right. And so we've got 2,115,000 births divided by 126,200,000. Multiply that by 100 to get it into a percentage. And I apologize. Let me get my calculator out. All right, so if you did the math out, you should end up with like 1.68%. All right, that's what we'll call it. So you do the death rate the same way, just total number of deaths over population. And so that's calculating either birth rate or death rate. Yeah, So that's that one. All right, so now we get to this one. Sorry, jumped the gun a bit. So the rule of 70 or rule of 72, and you'll see it either way. I'm not sure which way you might see it on an AP test, but you get the idea. So it looks at the doubling time given a percentage of growth, giving a rate of growth. And so, well, let me just work through this. So let's say that we had, a 5% growth rate. How long would it take that population to double? And all we do is multiply the growth rate into 70. All right. And so 5 goes into 70, that's a 1. So 14 times. And so if we had a 5% growth rate in population, it would take 14 years for the population to double. All right. And that's how you use, whoops, I just did the example down here. And that's how you use this rule of 70. All right. And so if there was a 2% growth rate in a country, so if you had a 2% growth rate, divide that into 70. And so again, that's 3. So 2% growth rate would be 35 years for the population to double. And so if we go back to this, you could look at the US. So the US is 0.3. So you would take 0.3 divided into 70. And that would tell you how long it would take for the population to double. All righty. And so here's just some other data, that I did in Excel. And again, using Excel is pretty awesome because it lets you do math real fast. And so you can see the different, here's crude birth rates, crude death rates, population growth rates. So these numbers, this 2.5%, was used to calculate this time for the population to double. All right, and so in Ethiopia, it would take them 28 years. In Fiji, it would take them 53 years. In Finland, they're not going to get there because they have a negative growth rate. So any of these negative growth rate countries, they're not going to obviously achieve any kind of doubling of their population. In the US, you can see it would take us 233 years if we just relied on the birth rates and death rates. All right, again, we have immigration, and so that could obviously shorten that up a lot. So you kind of get the idea. Birth rate, again, which is here, all we did was take the total births divided by the population, multiply that by 100, and that gives us this 15%. So they have a 15% birth rate. I didn't look up the death rates, but it's the same thing. All right. And so you can see here's Japan down here. Their crude birth rate is 7, and their crude death rate is 11, which is kind of scary. Okay. And so Japan's going to need to figure something out. Here's Mexico down here. Mexico has, it's higher for sure, 18 births, 6 deaths. Their population doubling time is 58 years compared to ours, and 6% birth rate. All right, or I'm sorry, 1.2% growth rate. All righty. So a couple of things that caused this change in population. The first is changing in fertility. All right, so there are some unintentional things that kept birth rates, that skewed birth rates. Countries did keep standing armies, and those armies were kept farther away, and so that could have had a depressing effect on birth rates. But some of the intentional things, industrialization, the incredible thing about industrialization is it helped replace a lot of manual labor. All right, and so fewer women were needed for some of those chores, and fewer children were also needed. And so it also allowed people to live longer. And so even though the total fertility rate declined, our overall population went up. All right, and so as countries have industrialized, women began working in factories. They lived in smaller houses near the cities, and so the family size was going to drop as a result of that. Children used to work in, we used to have lots of child labor, and now not. Public schools opened in large parts of the world, and instead of working, kids went to school, and we know that there's this direct correlation between education and the number of children. So more work in school, fewer children for women, and so that was one of the big, industrialization played a big role in that. And again, we've seen this one before, this chart here. This is just looking at the correlation between average years of schooling and number of children. And so as education opportunities open up for females, we see those fertility rates drop, the number of children per woman. Alrighty. So a couple other things that impacted changes in fertility. One of them is family planning. All right. So there was some technology here that allowed for more family planning. Women decided to have their first child later in life. They did have fewer children, had fewer unintended pregnancies, larger intervals between having children. And so in those places where that happened, the total fertility rate continued to decline. And so family planning, spread of family planning information and technology definitely helped change the number of children per female. Religion does play a role. Some religions believe in larger families, and so you might end up. These folks had a TV show after them, but religion does influence it. Some believe in family planning, or they're okay with family planning, and others would encourage larger families. So again, it's a cultural thing. All right. Life expectancy and infant mortality. So one of the big reasons for global population increase, and make sure you get these two, squared away in your head. Life expectancy has definitely risen in the last couple hundred years, and infant mortality has definitely dropped. And so if you have an increase in life expectancy, a decrease in infant mortality, you're going to see a bigger population. All right. In Massachusetts in 1850s, infant mortality is 130 per thousand. So infant mortality is it's usually for 1-year-olds. Sorry. So it's saying how many 1-year-olds per thousand don't make it. Okay, and so in Massachusetts, 1850, this would say for every 1,000 kids born, 130 of them died before their first birthday. All right, today it's 4. And so that is a huge decrease in infant mortality. So you have a larger number of kids making it, and you have people living longer. And so those two factors combined are going to lead you to a very high increase in population. So again, that's what happened here. We have a decrease in mortality and an increase in lifespan. All right, so take a look at these two. This is child mortality. This is from 1950. All right, so we have percentages over here, and the trends are the same for everywhere, which is awesome. They're all going down. So child mortality has been coming down for a long time, and these are life expectancies of different. I didn't get the. Oh, here's the colors. And so life expectancy obviously has been going up. And so again, when you get those two things, infant mortality down, life expectancy up, you're going to have a big population boom. Here's child mortality, 1800. You can see here's our key down here, our legend. So 30 to 60%. So you can just take note. There's no numbers really that I want you to remember here, but in 1800, huge child mortality across the globe. By 1950, it had started to change. Here's 4%, 5%, 18% in Russia. So some of these, 3% over here in Australia, which is good. And so those numbers have definitely gotten better by 1950. And then by 2015, you can see we're even better. And so a lot of that is, a lot of different factors for that. But and this is life expectancy. Again, so child mortality better, life expectancy getting better. Here, take a look at that. That's, 40 years old is the max. And so that was, 1800. So if you got past 40, you're doing pretty well. By 1950, we're at 68 years old. Canada's 68 years old, 49 here in Mexico, 35 in India, so it's still pretty low. But in the last 65 years, look at the progress. Look at the progress that's been done. All right, so now in the U.S., we're at 79 years, which is pretty impressive. Japan over here is at 84 years, which is even more impressive. And so you can kind of get a sense. So things are going well in public health, put it that way. And here's just an example for China, or I'm sorry, not China, for Thailand. You can see this is their age, okay? So this is the age when this goes over with this one, and this is the child mortality, infant mortality. And so, again, those two combined means increased population. And we're almost done here. So life expectancy, and this one's pretty cool as well. This is GDP per capita. This is income, basically. And so notice we have life expectancy over here and then income down here. And so you can see, there is this pretty strong correlation between income and mortality and life expectancy. So, and we'll get into that later on in the class. All right, so a couple of things that have helped with life expectancy, obviously better food production and nutrition. All right, so food production has become more mechanized. We do see improvement in technology like seeds and fertilizers, different farming techniques. Transportation has gotten a lot more efficient. If you go to the grocery store today, everything in the produce, half of it might be imported. All right, and take a look. In the U.S. in 1800, almost everybody farmed. Today, 3% of the population are farmers. This is more like 2% or less. But we are producing enough food for the world. Take a look at this. So this is one of the technology benefits. So don't worry about all these numbers, but this is corn grain yields since 1866. So notice 1866, our corn grain, the yield, so this is like per acre, how many bushels per acre. And that's what it is over here. And so you can see we were stuck at around 22, 25, something like that. And then it just took off. And so this is why, a lot fewer farmers are able to feed a lot more people. The amount of food per acre produced has skyrocketed. All right. And this is another reason, one farmer here can farm a ton of stuff because of all the machinery. Another thing that's helped is with life expectancy and food production. A lot of people who weren't farming are now going to college, and they're going off and doing other things and concentrating on other avenues that might make life better for everybody else. All right, so food security has definitely improved. There are still issues with food security around the world, but it has definitely become less of a problem than it was before. All right, farm families are becoming smaller because there aren't as many farm families as there were before, and a lot of these small farms are being consolidated into much larger farms, meaning that now people, instead of farming, again, can go do other stuff. Another big issue that's helped with life expectancy is public sanitation. And so we looked at the map in London about cholera. That was a waterborne illness. And so things like water treatment plants, things like being able to go to the bathroom in a toilet and then it goes out and the water gets treated, has done amazing things to prevent illness. If you are living in a place like that might have raw sewage, out in the streets, that is going to be a huge problem in terms of disease. All right. And so the creation of a public sewer system has done wonders for life expectancy in large parts of the world. Also, improvements in healthcare. We have vaccines, which have taken care of a lot of diseases. Something like smallpox. Smallpox killed 400,000 people a year for a while, and now there hadn't been any cases since 1977 of smallpox. And so, this is a wonderful thing with medical technology. Antibiotics, if you get an infection, antibiotics will generally take care of it. All right. And so this improvement in healthcare has done wonders for our life expectancy. All righty. So that's it. Our next unit is going to look at what they call the demographic transition model and Malthus, and then epidemiological transition. So anyway, hope you guys have a great day.